Hello everyone, welcome back. So today in this video, we are going to talk about the ECC algorithm. So it is the popular elliptic curve cryptography algorithm. So this video will be in two parts. So this is the part one where we try to understand about the elliptic curve cryptography, exactly how it differs from the RSA. And in the part two of our video, we will try to implement that elliptic curve cryptography by the use of the Diffie-Hellman protocol DHP using Python. So elliptic curve cryptography, it is an implementation via elliptic curves, as you can. And in the second part, we will implement the algorithm for the elliptic curve cryptography for the Diffie-Hellman protocol. The only prerequisite is you should have the basic Python programming knowledge and the concept of the cryptography techniques and the elliptic curve Diffie-Hellman protocol. The first elliptic curve cryptography is a asymmetric encryption, not the symmetric one. So elliptic curve cryptography or the ECC focus on the pair of keys of the web traffic. So web traffic means whatever send, and it is via the algebraic architecture of the elliptic curves. As you see, algorithm was proposed by Victor Miller and Neil Kopcipher in mid-1980s, so almost 8 years after the implementation of the RSA algorithm. RSA achieved the one-way encryption of email data and the software. So RSA is normally based on the prime factorization, as we have seen the RSA implementation. But whereas the elliptic curve is an alternative technique. Okay, it is a powerful cryptography approach and it generates the security key for public key encryption by using the mathematics of the elliptic curve. ECC proposed a plane curve over the finite field, as you can see in the figure, that makes up a point of the satisfying equation. So the equation is x raised to the power 3 ax plus b. The major concept is that any point can be mirrored over the x-axis, and you can see the x and y-axis over here. The curve will stay the same. That means any non-vertical line will intersect the curve in three places or fewer. It intersect the curve over here, over here. It is based on the approach that so any point can be mirrored over the x-axis and the curve will stay. Fewer means it can be 1. So the advantage of the ECC algorithm over RSA, as I have said, ECC is an alternative technique to RSA. RSA is dependent on the huge prime number, says the prime factorization, but ECC leverages the elliptic curve theory for the security. That means due to the elliptic curves and due to the smaller key size, and it is able to maintain the security. That means this continue to grow as a demand on the device to remain secure due to the size of the keys growing, so drawing on scarce mobile resources. So in contrast to RSA, ECC are structured over the algebraically finite fields. So RSA provide less laser bandwidth by RSA, whereas the ECC gives the significant bandwidth saving as is use the elliptic curves. On the comparison, it makes sense at the high level performance and the security. That's why the more websites are using ECC to secure the greater data, plane curve over a finite field, which make up the satisfaction of the equations. The third one, RSA encryption take more time, but ECC encryption process less time, because we will show how exactly that happens. The key, because when it comes to the RSA key bit length, ECC key of 384 bit that requires the same level of RSA of 7680 bit. RSA, as we have already seen, developed in 1977. It's towards the end of the tenure, so there are several successful attacks over the RSA, but ECC currently is in process, has attacked but considered more powerful and safer, and developed almost after 8 years, is still considered today because of the power of the elliptic curves and the fitting over the plane. And the another one, so the key length, yeah. So exactly the key length for 80 security bits. So normally the ECC requires 160 key, but here in the same case, the RSA require 1024 key, so which is significantly more. So there is no linear relation between the size of the keys between ECC and RSA. So an RSA key size is twice as big and does not translate into ECC size that is double. That means this is the compelling difference between the key generation and signing are subsequently quicker than RSA. Also saying that the ECC uses less memory than that does by the RSA because of the less bits of the keys. There are several algorithms. So when it comes to implementation, that is based on the elliptic curve arithmetic. So the first one is key agreement algorithm, which we Diffie-Hellman algorithm. So that enables the two parties to share the secret over the insecure channel and use the elliptic curve private public key pair. Another one for the key agreement is the fully hashed. So MQV is the managed queue Van Stone algorithm. So it is an authenticated key algorithm and that use a key agreement protocol that based on the Diffie-Hellman scheme. Criteria when it comes is the encryption algorithm. So encryption algorithm, the first one is integrated encryption scheme. So we say is IES on the elliptic curve. So that is a public authentication encryption that use a key derivation function, so KDF, and which is the second category. And the another one, the second one encryption algorithm is the LGAML, so which we call the LGAML or electric curve or EC-based LGAML, elliptic curve cryptography, which is the public key cryptography that employ the elliptic curve discrete logarithm problem by the LGAML ECC. The third one is the digital signature algorithm, another category of the algorithm for the elliptic curve arithmetic. So the first one is the DSA, we call it as a digital signature algorithm. It's highly complicated public key encryption algorithm that is a type of public key cryptography for the algebraic structure of the elliptic curve with its finite field for the pseudo-random generators, digital signature, and other data. So that's why we called a digital signature algorithm. One for the digital signature is the Edwards curve. So Edwards curve, we normally say EDDSA sometime, or performing the first key or the first public key digital signature. So the primary benefits are the embedded service using the high performance secure implementation, signature with no branch or lookup operation. Altogether, there are almost already 6 numerous algorithms for the ECC based. So out of these 6, we will implement our ECDH, which is also known as the elliptic curve Diffie-Hellman protocol algorithm in our next video. I hope this helped and thank you for watching.